So let's continue where we left. In the previous video, we discussed what differentiation is. Then we're talking about rules of differentiation. And then we did the sum, how to differentiate the sum and additions. Sum and difference, that's additions, subtractions of what? Differentiation. That's also what we also embark on. So if you are new on this channel and you are watching this video, I've given a link in the description section in this video for the previous video. That's the part 1 of this section. You can check that one so that you can build your knowledge and understanding from there. Then you can watch this right away so that you get to understand everything, the nitty-gritty of this video and what you need to understand so far as differentiation is concerned. And make sure to subscribe, like and share our videos, and push it and share. Let's share to as students as possible. Let's share it as many students as possible so that we can grow this channel and you become what? My VIP member once you subscribe to this channel. So thank you as you go ahead to subscribe. So let's get into ready for the next section, which is part 2 of this differentiation, right? So we're going to talk about differentiation of what? A constant, right? Differentiation of a constant. That's what we're going to do. So we are saying that differentiation of a constant, time you differentiate a constant number, constant value, you get what? H results about 0. Anytime you differentiate a constant, you get to be what? 0. So for example, if I have let's say example 1. If I have if y is equal to, let's say 10, then dy over dx will be question mark, right? So I'm asked to differentiate. How would I differentiate 10? We are saying anytime you differentiate the constant, you get 0. And how would you get that? Let's see. So I have my solution here. So straight away I can say that I can write this y, which is equal to 10, and this I can say that this have an implication form. I can say that y can be written as 10 to the power of x to the power of what? 0. So that I will differentiate with respect to what? X. It can be anything, it can be a, b, or c. So you must still differentiate with respect to the term. So I can say that y is equal to what? 10 raised to the power 0. True. Because in number raised to the power 0 is what? 1. In number raised to the power 0 is 1. So I can therefore say that if I want to differentiate, and therefore say that differentiate y, differentiate what? The same rule of differentiation still applies. It becomes, so the 0 come and multiply the 10, and I subtract 1 from the 0. So it becomes 0 multiplied by your 10. And I have my x0 minus 1. I hope that is clear. So therefore I can say that therefore my dy over dx is equal to 0 multiplied by 10. Number multiplied by 0 is what? That's 0, right? So all the term here will be 0. So it will be what? 0. I hope that is clear. Because we're able to write that y is equal to 10 in a form y is equal to 10 x raised to the power 0. So likewise, we also have, let's say if I was having y to, let's say, k, I'm asked to differentiate k. I can write the same thing as y is equal to what? K, let's say a to the power of what? 0. If I want to differentiate y with respect to a, so I can say that therefore differentiate y, differentiate what? A. Differentiate y, differentiate is, I can say that here the 0 will come and multiplied, the 0 will come and multiply k. Then I have my a 0, then I subtract 1 from here. 0 multiplied by a number is what? 0. So therefore I can say that my dy over the a is equal to what? 0. So that is how the constant rule is applied. So you can engage more to deal with more questions on that as well. So let's move on and talk about differentiation of an exponential function. Differentiation of an exponential function. Differentiation of an exponential what? Function. differentiation from the exponential function. Okay, so let's get into it. There is this symbol on our calculator. If you can check, I don't have mine here, but it's mostly represented as this. You can see on a calculator like an E that has been kind of so I say elongated in the more vertical, but very small E. It's not like the normal E, but this E is genuine. It's on a calculator. This E, we use that one to represent the exponential what form that we are talking about. Not necessarily an exponent of what number, but I'm just using this E which is on the calculator. It has a value. When you punch the calculator, you get a value for it. Just a value for it. So that's what we mean by differentiation from an exponential what function. So here, so in a functional form, in a function form, it will be like y is equal to, I'm using E for the benefit because it has the name, but I'm using E for the purpose of what understanding, raised to the power f of what x as a function, right? So for example, if I'm asked to differentiate it, for example, let's example 1. If I'm asked to differentiate if y is equal to that E raised to the power 5x plus, let's say 2. So let's have the differentiation for this. Divided by the x will be equal to what? So here in simple term, we are saying that we differentiate the function here, then that's what we are trying to talk about. So when you check the differentiation with an exponential, this E is a bit different from the normal that we are using. With that, if you want to differentiate, you differentiate the function, then you multiply your result by the E, then you repeat the same function. So it becomes, this is what I'm trying to mean, it becomes f prime. Anytime you see prime, that's the first derivative, you have changed it, you have differentiated. So f prime of x, then I'll have that E being repeated again with the same what function that was given, f of x. Here's what we mean. Okay, so anytime we have a differentiation in this form, just differentiate the function here, then after that come and multiply by that E, then repeat the same function that was given. So for example, I have y is equal to E 5x plus 2, then my dy over dx will be what? Then dy over dx will be equal to what? Question mark. So I can say that my solution here, I can say that y is equal to E 5x plus what? 2. So I can say that my dy over dx will be equal to, so I will differentiate the 5x plus 2. So differentiate individual, that is addition and subtraction form. This is addition of a differentiate. So if I should differentiate 5x, meaning that it becomes what? 5, right? So if I differentiate 5x, it's 5, right? Because, and then it becomes, let me do that work in here. It becomes 5x, which is what? 5, then multiply by 1, then x 1 minus 1, which will give what? 0. And I'm raised to power 0 is 4. So it becomes 5, right? When you differentiate constant, we said anytime you differentiate constant, get what? 0, like what we have done here, 0. So 0, so it means 5 plus 0 is what? 5. So we'll be having 5 multiplied by the E, then you repeat the function that was given, then you repeat it here, so it becomes 5x plus what? 2. So therefore your dy over dx is equal to 5 that E, I'm using E for purpose of understanding because that's the name, right? Then you'll be getting this as your final answer. So you see this one is a bit different from, but it's although the same differentiation rule, but here you need to differentiate the function at the top, then you come and multiply with the E, then you repeat what the function what again. So that is the difference that it makes. But aside that, the general function, if you have any differentiation question, the general rule still what applies. So let's move on and talk about differentiation of. Okay, let's take more examples on that. So example, let me say example 2. If y is equal to the exponential e, which is 2x plus, let's say 2x squared plus 3x minus 4, how would that one be? So with that, I have your solution here. Straight I can say that my y is equal to, just repeat, e 2x squared plus 3x minus what? 4. So I can say that my dy over dx, I'll differentiate this function, the whole of the 2x squared plus o. So let's differentiate and see. So I'll have anytime I differentiate 2x squared, it becomes what? The 2 multiply what? The 2, then I get 4, then I subtract 1 from these 2, then I'm getting what? 4x. So it becomes what? 4x. Now we know we can straight away differentiate without going through the order of the steps, straight away, right? Plus, when I differentiate 3x, I'm getting what? 3. Because the exponent is 1, so I multiply by the 3, then I subtract 1 from the exponent, I get 0. A number which supports 0 is what? Is 1. So I get 3. Then if I differentiate the constant, I'll get what? 0. So minus 0. Then I'll multiply by the e again, then I repeat the function, the same function that was given in the question. So it becomes what? 2x squared plus 3x minus 4. Hope that is clear. So therefore I can say that therefore my dy over dx is equal to 4x plus 3. Because it's 2 terms, I need to bring bracket. Then I have my exponent 2x squared plus 3x minus what? 4. So that's how this aspect works. So you need to take care of that. All right. So note that always you apply. Very simple. Just differentiate the function, which is the exponent of what? Which is the exponent of the exponential symbol. Then after that, multiply by the exponential symbol. Then repeat the same function that was given as an exponent for the exponential symbol, and that will be all. Very simple. All right. So let's move on and talk about differentiation of what? A logarithm functions. Differentiation of a logarithm function. So differentiation of a logarithm, or differentiation of logarithmic function, logarithmic function. Sorry. Okay, function shortcut. Sorry. So let's flow. So with that too, if I have y is equal to, so the time we shorten it by using ln to means what? Log, len. So if I have y is equal to len of f of x, then I'm asked to differentiate this. It's very simple. This is what you need to do. You first differentiate the function, which is this, then you divide it by what? The original function. That is how the logarithmic differentiation works. Differentiate the function, then divide it by what? The original function, which is without what? Differentiation, without change. Okay, so I can say that therefore my dy over dx in this case will be equal to f prime of x divided by what? My f of x. How that's, so I'll differentiate the function, then I divide by the original function. So that is how this aspect to also work. That is differentiation for what? A logarithmic function. So should I, if I can have example here, example 1 under this, example 1, if I have, now let's be a bit diversified. If I have y is equal to, let's say a cube plus a square plus, let's say, 4a, which is the limb. Let me have the limb as part of it, shall we? The limb, very small n here, the limb. So if I should differentiate this, straight away I have my solution. I can say that y is equal to the limb, which is log a cube plus a square plus 4a. So straight away I can say that my dy over the a, this one is not x, now this one is what, a. So that's why I always tell you that take into consideration the term in case before you differentiate. So it's not always that they'll give you x, at times they'll give you other variables, so you differentiate with respect to what, that term or that variable. So here the length becomes, if I want to differentiate towards a cube, it becomes what, the 3 can multiply the coefficients of a, which is what, 1. So it becomes 3, and subtract 1 from the 3, so it becomes what, 3a squared. Then the same here 2 becomes what, 2a. Subtract 1 from, I'll multiply the 2 by the coefficient of a, which is 1, and I'll subtract 1 from it, so it becomes 2a. Then differentiate the coefficient, the exponent of a is 1, so I'll multiply by the 4, then I'll get 4, then I'll subtract 1 from the exponent a, then I'll get 0, so it becomes what, 4. Then I'll divide by the original what, function, which is what, a cube plus what, a square plus what, 4a. So that's how differentiation of a logarithm what works. I hope that is clear. Let's take another example. Example 2. If y is equal to, let's say, 3x squared minus what, 2. Sorry, I always fail not to bring the lane. So the lane, shortcut form of what, logarithm. So I can say that with my solution here, I can straight away say that my y, which is equal to the lane 3x squared minus 2. So I can say that my dy over dx will be equal to, so our differential, which is what, 2 can multiply the 3, so it becomes 6. Now subtract 1 from the 2, so it becomes what, 1. Then if I differentiate what, a constant, I'll get what, 0. Now divide by the original what, which is 2x squared minus 2. So I can say that is what, 6x over what, 3x squared minus 2. I hope that is clear. So that's also how logarithm of what, differentiation of logarithm functions works. So take notes and always apply with it. All right. So we'll end here for section 2 of differentiation. So we'll continue on the part 3 section where we discuss differentiation of a product of a function, quotient, differentiation of what, quotient as quotient rules, then other higher derivatives, and even go ahead to talk about chain rule differentiation. That's where the part 3 also takes effect on. Then we continue to talk about implicit and other functions in the next or the subsequent videos that will be engaging on the differentiation. So if this video was helpful to you, please go ahead to subscribe and make sure to like and share this video so that we can reach as many students as possible and become champion with you, and I become champion in the market so that we can excel in our various academic studies. So this is Larbi Premium Educational Consult. So stay tuned with us and become a VIP by subscribing to this channel and liking our video. So see you in the next video where we discuss other matters of quotient rule, products, and other aspects of differentiation. So thank you once again for watching this video. It's been a pleasure for me to come here to assist you. Thank you and have a blessed day. So bye bye.